Are you ready? Oh, Gert is leaving.
Yeah, I'm ready.
Okay. All right, so we're live. Welcome everybody to our next episode of OpenStack Online Meetup. Today with us is Gerd and Manisha from Ravello Systems. Gerd will speak about how to set up OpenStack on AWS or GCE for dev test with Ravello Systems. And with this short introduction, let me hand over to Gerd. Oh, maybe one more thing regarding logistics. In case you have any questions, feel free to ask those either via email, rafael.newth@gmail.com, or via your IRC. We are on the OpenStack community channel, which is #OpenStack/community, or via Twitter, OpenStack_OM. All right, Gerd, the stage is yours.
Thank you, Rafael. So, yeah, welcome everybody. We're going to talk about installing OpenStack on either EC2 or Google Compute today. So, of course, we all love OpenStack, but we know that it can be quite difficult to install it, right? We have there is requirements that we need to have on hardware and on software. And so generally, starting a new OpenStack, especially a multi-node, non-dev stack installation from scratch can be quite time-consuming. And today we're going to show you how we can do this using the Ravello system, which should be a lot faster and does not require you to scrounge for any hardware. So I'm going to share my screen here, and then we're going to go through a small presentation. Okay. So that is my screen, and then we're going to go full screen. So Rafael, if it's not visible, then let me know. Otherwise, I'll just gonna continue. Okay. So indeed, as mentioned, my name is Geert Jansen, and with us we also have Manisha Aurora, and we're both at a company called Ravello Systems, and our Twitter handle is @Ravello Systems. Okay. So the agenda for today is basically to demonstrate how to install OpenStack from scratch. With no hardware required. And before we get to that, I want to give a small introduction of the service that we're going to be using for this. So this is the service that our company has built. The company is Ravello Systems. And we'll talk a little bit about nested virtualization, which is a technology that we use for this purpose. And we'll also talk about double nested virtualization, which specifically in the case of OpenStack is required. Okay, quick introduction on Ravello Systems. So we're actually the same team that built the KVM hypervisor, which is now the sort of default hypervisor for many of the public clouds today, and it's been present in the Linux kernel since quite some time. So we've got a lot of experience in nested virtualization. The goal of Ravello Systems is basically to make the cloud look more like the data center. There's a big sort of impedance mismatch, if you will, between the data center and the public cloud. They, they behave quite differently, especially if you think about, more enterprise applications. So, low-level networking technologies, for example, or multi-tier applications where you want segmented networking, or even OpenStack, which requires Intel VT or AMD SVM, the hardware virtualization features. So from those angles, the public cloud looks very different to the data center, and the goal of Ravello is to make that difference go away, and we do that by employing nested virtualization as well as software-defined networking. Okay, so let's talk a little bit about the technology. So so the evolution of virtualization, I tried to depict it here in this slide. So obviously everything started out when everything was physical. Then VMware came along and people started consolidating using virtualization. It started out on Windows, but recently, or in the last couple of years, pretty much everything is being virtualized at enterprises. And then what Ravello Systems did is we created this new hypervisor called ISVS, which is a hypervisor that is created to run in the cloud. Normally, it is not possible to run a hypervisor in a virtual machine. And this is because all recent hypervisors require the hardware virtualization features. So that's Intel VT, and on AMD it's called SVM. Those features are, typically not passed through to the guest. So this is true for all public clouds today. None of the public clouds today does this pass through. There is like a possibility to do it in the data center with VMware. But if we're talking public cloud, then the option of using nested virtualization is not there, because the nested or the VT features are not passed through to the guest. So how does HVX solve this, and how can we actually run a hypervisor in a virtual machine? This is because HVX was sort of built up from the ground to run inside a virtual machine. And the way we do that is with a technology called binary translation with direct execution. So binary translation was invented a long time ago, actually, by Digital Equipment Corporation, when they wanted to port, I believe it was the VAX machines to the Alpha machines. So they needed a way to have binaries that were compiled for one architecture run on another architecture. And the approach they used for that was called binary translation. So in essence, what it does, it looks at the compiled code. It will look for things called basic blocks, which is basically a sequence of instructions without any branch instructions in it. It will, at runtime, decode the instructions and translate them to a different instruction set. The result is then being cached and directly executed on the CPU. So that's where the direct execution comes from. Now, this technology can not only be used to run one architecture on another architecture, it can also be used to actually run virtual machines. Because what we can do is we can actually inspect the instructions that the virtual machine image is executing, and if those instructions are non-privileged, we just let them through directly without even translating them. But if the instructions are privileged, i.e. kernel mode in the guest, what we will do is we will apply that binary translation technology. We will translate the privileged instructions to harmless equivalents that do the same thing, and then we execute those. So the guest will actually still think it's running on the real hardware. It still thinks the guest kernel can execute privileged instructions, but instead all those privileged instructions are translated into something harmless, but nevertheless with the same side effects. This is the same technology that VMware used in the 32-bit era. Obviously they've been along, I believe, since '99, but I can be mistaken. But anyway, no, actually no, a lot earlier, something like the early '90s or mid '90s. At that point, the Intel virtualization features were not existent, and so VMware had to actually resort to binary translation at that point. They implemented it for 32-bit, and it actually worked quite well. But then when 64-bit came along, VMware did not actually port their binary translation approach to 64-bit, because this was the same time that Intel and AMD launched the hardware virtualization features. And so instead of doing binary translation for 64-bit, ESXi gained 64-bit support only with the VT and SVM features, which is actually a lot easier to do, because with these features, writing a hypervisor actually pretty straightforward. One example here is KVM. KVM, the first version, was written and got included into the Linux kernel in about 3 months. And this was just because using the VT features is actually pretty straightforward to write at least the basic version of a hypervisor. Now, obviously, it gets more complicated when you want to have scalability and performance and live migration and other things. But the basics is actually quite simple. So, long story short, we cannot use those features, so we have to do binary translation. As far as we know, we're the only company that has ever developed a 64-bit binary translation with direct execution. And this allows us actually to run VMware and KVM guests unmodified on any public cloud. Amazon Web Services, Google, HP Cloud, and a few more. Just sort of quickly elaborating on this can run VMware and KVM guests. The nice thing about our approach is that we can actually be that we can pretend to be a different hypervisor than we really are. So our binary translation, we configure it to either look like VMware, and in that case, will behave like VMware does. We'll implement the VMware devices, or like KVM, in which case we'll implement the KVM devices. So not only can we run guests, we can also pretend to those guests to actually be VMware, which means that you can actually take a VMware image, run it in Amazon on our nested hypervisor without doing a V2V migration. So there's no migration needed for changing the drivers or changing the file formats or anything like that. It will just work. Okay, so this is then combined with an I/O overlay. The nested virtualization gives us the abstraction layer for running the VMs. The virtual devices that we implement connect to our I/O overlay. So our virtual NICs connect to our software-defined network, and our virtual storage adapters connect to our storage virtualization solution. So this allows us to complete a completely isolated multi-VM environment in the cloud that is connected by a private network that runs on top of our overlay network, and where the storage is mapped locally to each of the VMs, but in the backend that storage is then being served by the block storage native to the cloud that we're operating on. Okay, so still talking about the general use case for Ravello, and then we'll get to the nested squared virtualization, which is required for the OpenStack. We'll get to that shortly. So our base use case is the following. So say you have a data center application environment, which is typically more complicated than your idealized web application, which has like a stateless web tier, one database, and a load balancer. And these enterprise applications are more complicated than that. They might have multiple subnets. They might use VLANs for segmentation. They might use different operating systems. But anyway, so this would be a data center application environment. And then we can actually embed that or encapsulate that and run it on any cloud. So this is, I think, an important point. So using our nested virtualization technology, using our software-defined network and our storage virtualization, we can actually take an entire application landscape, encapsulate it into a single entity, and then run it on the cloud. And sort of the difference here is that for us, the unit of management is the application, which consists of the multiple VMs and the networks and storage, but not the individual VM. So that makes the management that we provide sort of on a higher level than just the individual VMs. The unit of management for snapshots, for cloning, for starting, stopping is always the application, which is the whole shebang of all the infrastructure required to run your application stack. Okay, so let's get to the nested squared virtualization. So on the left again, you see the basic nested virtualization case that will allow us to run VMware VMs unmodified on the cloud. But then what we added on top of that was that in HVX, in our binary translation hypervisor, we actually provide a virtual version of the Intel VT. Actually, in our case, it's AMD, so the AMD SVM instruction set. So whenever the nested guest will run, it will, for example, query the CPU, is SVM available? Our hypervisor will say yes. If the guest will perform any of the instructions from the SVM instruction set, we will actually see that instruction, because anyway, remember, we were translating the kernel code in the guest, and we will actually, on the fly, translate that instruction with something equivalent, but that can be run, in fact, directly on the CPU. So even if the host CPU does not have those features available. And that's sort of the crux or the underlying technology that allows us to run OpenStack in the cloud. We can actually, because we provide these VT or these SVM features, we can run a hypervisor in a nested guest, and then the hypervisor, in this case, typically KVM, but it can also be ESXi or Hyper-V. By the way, those two later ones are future features, so right now it's KVM. Those can actually run nested guest again. So if I run a nested Linux machine as a VM on HVX, I will see in proc CPU info, I will see the SVM feature set, I will be able to load the KVM kernel module, I will be able to use any virtualization management system that uses libvirt or any other KVM based management. Okay, so hopefully that was clear. So let's have a look at how we can actually install OpenStack on Amazon Web Services or GCE. Okay, so hold on. So this is the environment that I'm going to shortly create. So I'm going to have a 3-node setup with a controller and 2 compute nodes. The controller will run Nova, Horizon, Glance, and Neutron, and the compute nodes will run obviously the Nova compute and the L2 agent. Everything will be based on CentOS, so not Ravel 6 as mentioned here, but on CentOS. And then everything else will be running on HVX. It will have 3 networks that connect the 3 nodes. So I have an external network that via a router is connected to the public internet. We have a management network that the nodes or the services use to communicate with each other. So that's where the Keystone API and the Nova API sits. And then finally we have a VM data network, which is used by Neutron to provide VLANs on, and then each VLAN will actually be backing one of the tenant networks that is provided by Neutron. Okay, so the undercloud. So by the way, sorry, installing OpenStack consists of 2 steps. The first step is installing the undercloud, which is in essence is this infrastructure on which we're going to install OpenStack. And then as a step 2, in the next slide, we'll actually be installing OpenStack itself. Okay, so the first step is, there's just, some more words here on what the undercloud is. I think people know what this is, but in essence is this infrastructure on which we're going to install OpenStack. The unique feature of the Ravello system is that this infrastructure that we're going to deploy shortly has hardware virtualization and full level 2 or layer 2 network access available. This is highly desirable for OpenStack because obviously you want to run your instances at full speed. You don't want to run them in emulation mode. So that's why hardware virtualization is very good to have. And secondly, the level 2 network access is very useful because then you can use all kinds of advanced neutral networking modes. So for example, the modes that we're going to use is VLANs, but you can also use VXLANs, GRE tunnels. The L2 network that connects the nodes together is fully L2 clean, which means you can do non-IP things like VLANs, but you can also do broadcasting and multicasting. And those are things that are typically not available, in the standard cloud network. Okay, we also call this a virtual bare metal undercloud because usually these underclouds are actually bare metal. In our case, it's going to be a virtual bare metal. And we're going to use a script called Ravello create nodes, which is part of our software development kit, to actually create this undercloud. I'm going to show you how to do this. So the command is actually this. So the script is Ravello create nodes. And what I need to say is basically I need to give the type of nodes that I wanted to create. So I want 2 CPUs in this case. I want 4 gigabytes of memory. I want to have also some root disks, and the first root disk of the first node will have a root disk of 200 gigabytes, and the second and the third and further nodes will have 50 gigabytes. And you specify it like this as a comma-separated value. ---- is SVM to enable the nested virtualization. I'm going to add 3 networks, like I explained earlier. One for the external access, which is the 192.168.0 network. Then I'm going to add a network for management, which is this network. Okay, I should obviously say ---- network. And 10.0.0.0/24. And then what I'm going to say is also want to have inbound access first node is going to have a public IP, and the other nodes are going to use port forwarding. And then what I'll do is I will also specify the image, which is in this case a CentOS -6 image. And I will specify the count, which is 4. Oh, and by the way, I want to have a user name, which is my Ravello account. Oh, and I forgot, I want to have specify key pair as well. Key pair is separately uploaded to Ravello by the management UI, and we'll have a look at that shortly as well. So as you can see, this command is everything needed to get the undercloud going. Let me just fire it up. Okay, so it now published this this application. The first time I did this, and I didn't have the automation available, it took me more than a day to actually install these 4 nodes, because each node has static IPs, so it means they're all different. So I had to, first of all, upload a DVD, install everything from DVD, then log on to each of the nodes, and deploying my SSH key, then configuring the static network, making sure you don't make a typo somewhere. So it took me a long time to do it, but with this, automation, it's a matter of typing in this command line, and about 5 minutes later, you have a working undercloud. So what I want to do now is I want to quickly show you how it looks like on the Ravello on the Ravello side. So I want to actually get out of full screen, and I'm going to log on to the Ravello Management Console. So the one that I just created is called Cloud Zero. And first of all, by the way, it's good to mention that Ravello is a software as a service model. So you use the system through our web interface, and and then everything is done through the web interface. The second thing to mention, just to clarify, is that although these systems run in the cloud, so in this case you can see this system is published to Amazon Virginia, that is something that we take care of ourselves. So we actually bill the customer for this service at roughly the same price as the underlying cloud, and then we publish this actually inside a managed account or multiple managed accounts that we have with the cloud providers. This allows us to do some advanced scheduling and consolidation, for example. Okay. So I have these 4 VMs here that I created with the script. You can just click on them. You can see very similar to how you would expect this with the ESX. So you can see the CPUs, memory size, the networking is set up here. So each network has a static IP, 1 disk. The services are basically external entry points that you can use to get inbound access to certain service. Configuration management, so you use Cloud Init to push down the networking configuration and also the key pair to the guest. Okay. I also want to show you the networking view of this. So this is the networking view of the application that we just created. So we created 3 networks, and they're visible here. 1, 2, 3. The first network is the only one that is connected to the internet via this router here. The second network is a management network, which is a private network to the application. And the third network is a network where the VLANs are going to run, and basically on top of VLANs, the tenant networks. Okay. When the application is done, we'll see it. I'll go shortly to an application that's already published, so we don't have to wait for it. But once it's done, we can do things like save it as a blueprint. So we'll actually can create a snapshot of the full application, including all its state of all the VMs. That blueprint can then be instantiated as many times as you want. So there's a library of blueprints, and you can then save your famous or your golden OpenStack instances, or you can save instances that maybe are troublesome and you want to get back to them later for development and test. Just as you use snapshots in the VMware case, you will actually use full environment blueprints, as we call them, on Ravello. Okay, so after that, let's get back to the presentation. So the second step then in the installation, once the undercloud is installed, we can install OpenStack. In this case, I decided to install RDO, which is of course Red Hat's OpenStack, but this will work, with any OpenStack that you so choose. So the process looks like this. It's not fully automated. There's a few manual things that need to be done. It's in essence going to take 15 to 20 minutes. Put them here. Many of these are specific to RDO. So if you're using another OpenStack, Mirantis or Ubuntu or SUSE or whomever, it's going to be slightly different. But in case of RDO, it's in essence installing the RDO RPMs, the installer, which is called PackStack, and Open vSwitch, which we need for Neutron. We need to create a BR-X bridge, which Neutron uses for external access. We'll create an answer file with PackStack. We'll basically edit the answer file, put in all the IP addresses of the host that we want to install, and we need to also configure the Neutron networking. So we need to basically tell Neutron to use VLANs, and we need to tell it which VLAN tags it can use, and how these map to bridges and interfaces. Once the answer file is done, and by the way, these instructions are actually on a blog on our website, and that's actually soon to be updated with the most recent version of those instructions. So you can also go to our blog on our website and have a look at this, after the presentation is done. We need to then fix a little bit of the HTTP configuration, because the outside there's going to be an internal network, and it's going to be the public internet. And we use port forwarding to have certain ports on the outside map to services on the inside. So when you will access, for example, a Horizon dashboard, you're actually accessing an IP address, which is a public IP address, that's going to be mapped to an internal address in the 192.168.0 range, which is our external network. So in order to make sure that it works, we need to add some HTTP configurations. Basically, we need to make sure that the default vhost is configured correctly, and that we can accept arbitrary host headers. We need to fix the no VNC configuration to refer to the public IP. Number 8, very importantly, we're going to set the libvirt type to KVM, so we get the full performance of hardware accelerated virtualization rather than the emulation performance for QEMU. And then we can load the 0s instance, and it can actually see it booting and see it working. Okay, so that's the installation process. Now I have a version ready that I prepared earlier, and it should be this one over here. Again, 4 VMs. So this one, I completed step number 1, creating the undercloud, and then I went through all the steps of the second part, which is configuring and installing RDO. So I'm just going to open this up here. Okay, so I'm just going to log on as the admin user, and I just need to quickly get the password here. And just need 1 second to make sure I'm logging onto the correct system. So these all have random passwords set, so that's why I have to look it up. Hopefully this is going to work. My internet connection is a bit slow, but okay. So we're actually now in the Horizon dashboard. So let's have a look around. obviously what we're going to see is the hypervisors. So in this case, there are 3 hypervisors. The type is mentioned as QEMU, which is correct because also our hypervisor is based on QEMU. But this is QEMU for the devices with the HVX accelerator in essence. Right? So QEMU can use KVM as an accelerator if the VT features are there. In our case, it uses HVX as the accelerator, offering binary translation. So that's why the type is listed as QEMU. Some other things we could have a look at is, for example, the networks that are there. This is just the standard, networks that are provided by the default install of RDO. And let's try to fire up an instance. And actually, what I'll do is I'll fire up the instance from the demo account, which is the account that is actually the owner of the networks that were already provided. So I'm going to sign out here, and then I'm going to log in as a demo user, and I'm going to install, or actually fire up an instance. Make sure I get the right password here. So, okay. This is correct. Yep. Okay. So as you can see, because this is not an admin user, I only have my project pane here. I don't have the admin pane. So let's go to instances. Let's launch an instance. Let's call it very creative name, and we'll boot for image. And we'll use the Suros image, which is sort of a standard image as part of the RDO. Don't have any key pairs. So we're going to connect to a network called private. I'll show you the network topology in a bit. And we can actually launch it here. It's going to take a couple of minutes, so we can get back to it in a minute. In the meantime, let me show you the network topology. Okay, it's a little bit slow. Okay, so there's 2 networks. One is the public network, and we have a router provided by the L3 agent, by the Neutron L3 agents. And then we've got a private network over here, which is where my test instance is attached. It's currently in the building state, and this is its IP. Private network, let's see if we can edit it from here. Actually, let me show it from here. The private network is actually a VLAN, but I can't see it here. I think you can see it in the admin interface, the admin side. What you'll see there is that it actually has what's called a segmentation ID. So you'll see that this network corresponds to, for example, VLAN tag number 2 or number 3 on the 3rd network that we created at the Ravello side. Okay, let's leave the instance booting. We'll finish up the presentation. I'll show you that it runs, and then we can answer some questions. So let's go back quickly to the presentation. There's really, quickly around use cases. Why is this useful to run OpenStack in the cloud? We position it mostly as development and test. Obviously, if you want to run production, OpenStack is obviously used for many private cloud deployments or even public cloud deployments. That's done better on the bare metal. But for development and test, which is a large fraction of use cases or workloads in enterprises, it makes perfect sense to do it in the cloud. You don't always need all your instances, but when you do, you don't want to wait. So it's very difficult to properly allocate the right number of resources for development and test workloads, because it's a trade-off between not having your developers wait in the time of a crunch versus having idle systems sitting around when nobody's using them. So that's why it's ideal for the cloud. So things, if you're, for example, an enterprise trying to install OpenStack or running your own OpenStack, you could use it for upgrade testing. If you're an OpenStack developer, you could have your own private OpenStack or OpenStacks running in the cloud. You can spin them up when you need them. You can test more complicated things like VLANs or Pixie booting. Those kinds of things that would be difficult, to emulate on a developer workstation. So those are all, examples of development and test workloads that are, where it makes sense in our view to run those in the cloud. On the ISV side as well, say you have an OpenStack distribution, you want to harden it. Ideal, to do that at least part of the testing in the cloud. Training, say you want to train, you have an application that works together with OpenStack, for example, or the application is an OpenStack distribution itself, and you want to have an easy way for your end customers or prospective end customers to get access to your software. You can actually load it up in a Ravello environment and give access to your customers like that. So it can shorten sales cycles significantly because your customers don't have to for a POC get hardware. Can maybe take weeks or so, or not more, for customers to typically arrange hardware, arrange data center space, and so on. And if you can do it in the cloud, that's obviously cutting a large time out of a sales cycle. Demos, professional service or sales engineers, system engineer demos. Online free trials. Somebody, if you're an ISV and you have a product that you want to sell, and rather than doing all kinds of managed POCs, you want to just give a quick short exposure to your product to somebody who's just passing by on your website. Using a system like Ravello, you can actually automate that and give him access to the real thing, rather than some kind of a mock-up or video or screenshots. On the enterprise side, things like upgrade testing, things like doing a project to compare multiple OpenStack distributions, in case you want to have your own private clouds. Those are all things that you can, where it would be useful to run OpenStack in the cloud in case you are an enterprise. Okay, next steps. So, if you're interested, you're very free to request our 14-day free trial on our website, mentioned here, together with the instructions in this webcast and in the blogs on our website. You should be able to get your own OpenStack up and running in no time. If you want something more managed, we can also offer a demo at the email it's mentioned here, demo-request@ravellosystem.com, or you can go to our blog and search for OpenStack. You'll find all our OpenStack content. So before we open it up for questions, let me quickly check if the instance that we created is up and running, and which would be cool, so I can show it to you. Okay, it's active. So let's go to it. Yeah, the log, and let's open the console. So there is, I think, see if this works. I think there's a browser permission issue, but if I open it up in a full screen, it should actually work. Okay. See? So this is nested. This is an instance running on our OpenStack, which runs on virtual hardware, and it's not running emulation. So it's very quick, as you can see. You can also look at the boot messages to show you that it's a full virtualization solution. Yeah, that's I think that's pretty much it for the demo. So I'd like to hand it back to Raphael and see if there's any questions that you guys have.
Thank you so much. Thank you so much for the demo. So all of you guys who are watching us live, if you have any questions, ask them now via IRC. We are on #OpenStack/community or via Twitter, OpenStack_OM. And actually, one question came in, Gerd. Why do we need to nest a VM on a cloud-based VM? Why don't we just install OpenStack controller directly on the VMs we got from AWS?
So you can actually get the controller. You could install that directly on AWS. But what is the controller going to manage, right? It's not going to manage, a KVM hypervisor that's under your control, right? You could get the Nova and everything up and running, but the Nova Compute Agent, if you would install that on a EC2 or Google Compute VM, then it would not be able to use KVM. So you'd have to run in QEMU in emulation mode, which means that the performance of your instances will be probably 1% of what they are if you wouldn't be running them in nested mode. So it's just really, really slow. And the second thing is on the networking side. So if you wanted to use Neutron, for example, to create a VLAN-based networks between the VMs, between the instances that you manage on OpenStack, it wouldn't be possible running it straight on Amazon, because network in Amazon or in Google or in Azure, it doesn't support broadcasting, it doesn't support multicasting, and it also doesn't do VLANs. So that's a second reason why installing straight on AWS is not going to be, give you a real representative environment.
All right, thanks. So it looks like we don't have any further questions. Let me just check for last time on IRC. Nope. Stephen, do you see any questions coming in? Oops,
No.
Stephen's not there. No.
No,
Okay.
I'm here.
All right, guys.
Now, I did have a question though myself on the hypervisor that you mentioned. So let me just make sure it's right. The only way to actually run OpenStack in the cloud is to use that specific hypervisor that you guys have created. Is that the product that you're actually selling, or is that, am I not getting that correct?
Yeah. So let me answer two questions. So under the assumption that you do want to have advanced networking and you want to have good performance, then our solution is the only way that we're aware currently to run OpenStack in the cloud. As I said, it is possible to run a hypervisor using QEMU in emulation modes, but it's going to be excruciatingly slow. Like think 5 to 10 minute boot times for an instance, and about 1% of the CPU performance that you would normally get. So with that caveat, yes, you would need something like Ravello, and we think we're the only one who have a product like this today that supports both nested virtualization as well as level 2 network access. And then the second question, is this a product that you currently sell? Yes. The product is, the service that we developed is not specific to OpenStack. So it started out as a way to, make the data center look more like, make the cloud look more like the data center. So imagine you have a complex enterprise application, with an Oracle database and maybe, HA proxy and some other, enterprise technologies. Those are not easy to get, into straight Amazon instances. And so with our solution, you can actually just take those VMs, upload them into our service, and run them in Ravello on the cloud without any changes required. So no VDV changes. If you use static networking, you can still use exactly the same static networking and IP addresses in the cloud. So no changes required. That was the original product, but then we basically saw that a lot of people wanted to run OpenStack in the cloud, so we added this specific feature, which is this nested squared. So the nested virtualization that allows a nested VM on Ravello to be a hypervisor itself.
So I actually have one more question. I just want to make sure I understood correctly what I saw, and maybe other people out there have the question but they don't want to ask, so I will certainly do that. So if I get it right, what I saw was I have Amazon's public cloud, then you put what you call the undercloud, which is essentially OpenStack's cloud, then you have your hypervisor on top of it, and then we ran an OpenStack cloud, which then launched the instance. or did I add one too many clouds?
I think you added one too many. So we've got obviously you've got Amazon, the hardware. Amazon runs Zen as the hypervisor. It doesn't run OpenStack, but in this case runs Zen. Actually, your stack was correct if we were thinking about an OpenStack-based cloud. So say we're talking about HP, then you're right. HP got hardware. Then they have OpenStack managing that hardware. We would then buy instances with HP. We run our HVX on that. Then on our HVX we run the underclouds, and on that we run an OpenStack again. And those run in nested instances. So it's a lot of nesting, but on the other side, and people sometimes do get concerned about things like performance, but it turns out that actually the approach we use, binary translation, is a lot better suited for this higher levels of nesting than the sort of trap and emulate approach that you use with the DT features that VMware uses. Because what you get with trap and emulate is that the number of context switches are going to escalate. So first level nested, yes, you might have 100 context switches or 100, they call them VM exits, which turn into 10,000 on the second level, and so on. So there's like a sort of multiplying effect every layer you add. Well, with our approach, because if we do the translation, we effectively run the most deepest level guest directly on HVX itself. So that's why, in our case, the binary translation is actually not adding overhead to the second level of nesting.
So one last question, just so you can plug. Do you have a talk set for Paris that people who are listening want to vote for? Or I want to give you the shameless plug time. There's no problem.
Yeah. I appreciate that. Yeah, we do have actually. Manisha, can you quickly remember the title that we have there so that people can look for that and vote on it? Manisha, are you still online?
Yes, I am. So one of our customer, an ISV customer who is using our platform to do CI for their products and make them test them against OpenStack, they are using us. So they have actually submitted a talk. So if you go to the papers section and search for CI and OpenStack, you will see a paper come up by a person named Ibn from Spirent, and would appreciate if you guys go take a look at that and vote for it.
Cool.
And we may have, I just want to wait a second because Amitabh Day is joining the IRC and might have a question. He's out in Singapore, and if you know Amitabh, he never sleeps. He's clearly a vampire. So, he just hit me on another chat. So Amitabh may have a question, so let's just hold on 1 second. And I think that I asked all the simple questions I could, but I think this was an excellent demo that you showed today. And for those watching the online meetup or watching the videos, we're always looking for interesting topics and speakers. So do reach out to Raphael and myself, and we're happy to bring on great talks like this. This one was really very interesting. It was great to see. We appreciate Ravello today helping us. So let's give Amitabh 1 more minute. Maybe we can get a song and dance from Raphael while we wait this last minute to see if he has anything else. Will you guys have a booth at the summit?
Yes, we do. We are actually going to have a booth. So yes, please come and visit us, all of you OpenStack enthusiasts. While we're waiting, I just want to kind of add one note here. We have most of our OpenStack users are primarily using our system to set up these starter OpenStack instances, if I may call them that, right? These are folks either getting up to speed on OpenStack or people who are actually know OpenStack quite a bit and want to, have these installations set up in an on-demand manner without having to wait for physical hardware, so they can do their testing, they can test various networking configuration as Heath pointed out, they can develop drivers for OpenStack, they can test their products against OpenStack. So those are primarily the use cases that our customers are using us for, specific to OpenStack.
All right,
so it looks
guys.
like, yeah, go ahead, Raphael.
Yep, it's your turn, Stephen.
Well, I guess Amitabh doesn't have a question, so thanks for waiting. And I think we have another meetup next week. Is that correct, Raphael?
Yeah, that's correct. Same time, same place, Tuesday, 9 a.m. Pacific. And we have a talk with, let me just look it up, because we have so many talks this month. We actually have four hangouts scheduled for August. And the next one will be with John from SwiftStack. And he will talk about Swift 2.0, and specifically about the storage policies which have been launched with this new version.
Great. Well, everyone, thanks for joining, and I guess we're out of questions, and if you have more questions, we can always forward them on. And again, Ravello Systems, thank you very much today for your fantastic demo. We really appreciate it, and to everyone who watches, we'll see you next week.
Thank you all very much. See you next week.